This is a question from the third grade Perennial Maths test. It says, circles A, B, and C form four regions where they intersect. The numbers 1, 3, 4, and 6 can be placed in those regions so that each of the circles has the same sum. What is the sum? So I've drawn the figure with three circles in three different colors, A in green, B in blue, and C in pink. And I have marked the intersecting areas A, B, C, and D like I have shown in the chart here. So the clues that I have from the question are, the first clue is that the numbers 1, 3, 4, and 6 are placed in the regions marked as A, B, C, and D. I don't know which one is which, but A, B, C, and D would each have any of the numbers from 1, 2, 3, 1, 3, 4, and 6. So that's a clue for me. So I'll just write the clue here. A, B, C, and D are part of 1, 3, 4, and 6. And we'll have to figure out which one is what. That's the question. And once I figure out which one is what, then I can add up these numbers that belong to a circle to find the sum of the circle. The second clue I have is each of the circles has the same sum. So let's look at the three circles and see what the sum means. So if I look at circle A, the sum of circle A is 5 plus A plus B plus C. Let me mark that as 1. Circle B is similarly 2 plus A plus B plus D. Let me mark that as number 2. Circle C is 7 plus B plus C plus D. Now I have to play with these three equations, 1, 2, and 3, to simplify them and see what I can get out of those. So the first thing I'll do is look at the second clue, which is 1, 2, and 3 are all equal to each other. So let me take 1 and 2 first. Let me equate those two and see what I get. So I'll say equation number 2 is the same as equation number 1. Or if I expand what equation 2 is, 2 plus A plus B plus D is the same as 5 plus A plus B plus C. Now I see that we can simplify this even more. A and B are common on both sides. And I can move C onto this side and simplify it. So on the left hand side, I'll have D, and then since I'm bringing C from the right hand side to the left hand side, the plus C will change to minus C. And then I'll move the constant 2 that I have here onto the right hand side, so it will be 5 minus 2. Or D minus C is equal to 3. This is nice. I'll mark this as 4. Now let me equate 1 and 3 and see what I get. 1 is the same as 3 because the sum of circle A is the same as the sum of circle C. So from this, I get 1 is nothing but 5 plus A plus B plus C, and sum of C is 7 plus B plus C plus D. So if I simplify this, I know I can cancel out B and C from both sides, and I can bring D onto this side of the equation. So that will be A minus D. Since I'm moving D from the right hand side of the equation, a plus D will become a minus D once it's moved to the left hand side of the equation. And then I'll move the constant 5 from the left hand side of the equation to the right hand side of the equation to simplify it. So it will be 7 minus 5, or A minus D is equal to 2. Let me mark that as equation 5. And I have one more equation to go. So if I look at the equations, I have equated this with this, and then this with this. So the one thing that's remaining is equating circle B and C, which is this and this. Let me do that now. Much like what I did earlier, I'll equate 2, 3. And that's because the sum of circle B is the same as the sum of circle C. I don't know where this came from. Okay, so if I write this equation, I can replace sum of circle B as 2 plus A plus B plus D, and I can write circle C as 7 plus B plus C plus D. Again, if I look in both the sides, B and D will cancel each other out, and I'll move C onto the other side of the equation. So I'll get a minus C on my left hand side, and I'll move the constant 2 from the left hand side onto the right hand side. So that will be 7 minus 5. Sorry, 7 minus 2. Or A minus C is equal to 5. Okay. So now, since this is so spread out, I'll just summarize what I just did as part of equation 4, 5, and 6. I did D minus C is equal to 3. I did A minus D is equal to 2. This was my equation 4. This was my equation 5. And I have A minus C as 5. Equation 6. So I can't process this any further. If I do anything more than what I've already done, it'll start going in circles. So I now have to look into the other clue, which is these numbers A, B, C, and D. I have to pick these numbers from 1, 3, 4, and 6. Now this is where it gets a little tricky. How do I do that? So for me to do that, I'm going to create a chart with these numbers. I'm going to create a chart with these numbers. Let the chart be like this. One, 3, 4, and 6. One, 3, 4, and 6. Now one thing to see is from these equations 4, 5, and 6 that D is greater than C, and the difference between D and C has to be 3. A is greater than D and A is greater than C. Right? So the possible numbers are 1, 3, 4, and 6, as you can see from this table here. Let's do a subtraction and see what happens. I'll subtract the columns. What's going on? I'll subtract the columns from the rows here. So 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. 6 minus 1 is 5. Now I'll go to the next row. 1 minus 3 is 2. Minus 2. 3 minus 3 is a 0. 4 minus 3 is a 1. 6 minus 3 is a 3. Now I'll go to the next one. 1 minus 4 is a minus 3. 3 minus 4 is a minus 1. 4 minus 4 is a 0. And 6 minus 4 is a 2. I'll go to the last one. 1 minus 6 is a minus 5. 3 minus 6 is a minus 3. 4 minus 6 is a minus 2. And 6 minus 6 is a 0. Right? So knowing that A, B, C, and D would be any numbers that's in the rows and in the columns, let's look at where I find a difference 3. I'm looking at equation number 4, and let's see where I find a 3. I find a 3 here, and I find a 3 here. There are no other places where I have a 3. And since from 4, 5, and 6, the differences are all positive, I can easily leave out the ones where the differences are coming out to be 0 or negative, which means I can leave this one out, this one out, this one out, this one out. And I can pretty much leave everything on this side out. So the possible options that I have are either the numbers that are on the other side of the diagonal. So from equation 4, I see that there are only 2 ways in which I can get a difference of 3, which is either 4 minus 1 or 6 minus 3. So if 4 is true, then from 4, D is either 4 or 6. So if D is 4, then C has to be 1. Or D could be 6, and in that case, C would be 3. This is one possibility. From 5, which is this equation, I see a difference of 2. 2 is possible only here and here. So I can get 2 if A is equal to 3 and in that case, D has to be equal to 1, or this case, which is A equal to 6, and in that case, D has to be equal to 4. This is another possibility. And then from 6, the difference is 5. There's only one place where the difference is 5, which is this one. There is no other place where the difference is 5. So this has to be true. So in that case, A is 6 and C is 1. Since there are no other options for 5, this must be true, has to be true. There are no other options for a 5. Now if A is 6 and C is 1, then from here I see the only combination where C is 1 is D equal to 4. And I can use this to verify if D is equal to 4, is A really equal to 6? And it shows that A is equal to 6. So I can safely say that from the equations and the calculations, A is equal to 6, B, I don't know, I'm still to find out, C is equal to 1, and D is equal to 4. There are no other options. It can't be any other way. Right? Now remember, I was given the first clue, which is A, B, C, and D must have one of the values of 1, 3, 4, and 6. So I've got 1, I've got 4, I've got 6. I've got 1, I've got 4, and I've got 6. The only number I don't have is 3. So B has to be equal to 3. Now, let's look at equation 1, which is this equation. It said A is the sum of 5 plus A plus B plus C. So if I put the values of A, B, and C here, A is 6, B is 3, and C is 1, I get 6 and a 5 is 11, 12, 13, 14, and 15. I get the sum of the numbers in circle A is 15. Let me cross check with what I get for B. B from equation 2, from this equation, is 2 plus A plus B plus D is equal to 2 plus, let me put the values of A, B, and D here. A is 6, B is 3, and D is 4. So it's 6, 8, 11, 4 is 15, which is good. So I know the sum of all the numbers in circle A is the same as the sum of all the numbers in circle B. Let me do the last check with circle C and see what happens. Circle C from this equation is 7 plus B plus C plus D, which is equal to 7 plus, if I put the values of B, C, and D, B is equal to 3, C is equal to 1, and D is equal to 4, I get 15, which satisfies all the conditions here. So the question said, what is the sum? This was the question, what is the sum? So the sum, as we have found out, is 15 in all the cases. And the individual numbers A, B, C, and D are 6, 3, 1, and 4.